rule is that if a to the u power equals a to the v power, then u equals v. Okay, so for number 63, you're given 7 to the x power is equal to 7 to the third power. So if the bases are the same, then you set the exponents equal to each other. So it has to be just a basic exponential function. You can't have like a plus 4 over here or something like that. Okay, it has to be two basic exponential functions with the same base that are equal to each other. So what can we say about the exponents then? X equals 3. Okay, so that's solving that exponential equation. So that's a really quick, fast one as long as you know the rule. All right, look at 65. So that one we have 2 to the negative x power equals 16. All right, so 16, if we can write it to where it has the same base, then we can use this rule. So think about factors of 16. What are factors of 16? 4 and 4. And what are factors of 4? 2 and 2. So how many 2's do I multiply together to get 16? 4 2's. So it's going to 16 is equal to 2 to the 4th power. So if I can write it where it has the same base, then I can set the exponents equal to each other. So negative x is equal to 4. And then solving for x, you want to multiply both sides by negative 1. So that's going to give me x equals negative 4. Okay, look at number 68. So I have 1/4 to the x power. 1/4 to the x power equals 1 over 64. Okay, so I want to, since the base here is 1/4, I want to be able to write 1 over 64 with a base of 1/4. Okay, so think about 64. What are the factors of 64? So I need factors of 4. So think about 4 times what equals 64? 16. Okay, and then 16 is 4 and 4. So how many 4's is that? 3. So 1 over 64 is going to be 1 over 4 cubed. Okay, so I'm almost there. That it's almost 1/4 to some power. But I need to write the cube on the outside, so 1 is equal to 1 cubed, right? And as then, because 1 to any power equals 1, so I can write that as 1 cubed. And then as long as the numerator and denominator have the same power, I can write the whole fraction 1/4 to that third power. Okay, so as long as the bases are the same, then I can say the exponents are the same. Does that make sense? All right, look at number 80. So we have e to the 3x power equals e to the 2 minus x power. Okay, so bases are the same. It doesn't matter what the bases are, as long as they're the same, then I can say that the exponents are equal to each other. So 3x equals 2 minus x, and then we're going to solve for x. What kind of equation is this? Here's a hint. Linear, good. It's a linear equation, okay, because the x is to the first power. Okay. All right, so we want to get all the x's on the same side, so I'm going to add x to both sides. So 4x equals 2. Then divide both sides by 4. So x equals 1/2. Okay. Look at 82. Any questions on that one before we go on? Okay, 82. We have e to the 4th power to the x power equals 3. No, I wrote that wrong. Equals e to the 3x power times 1 over e squared. Okay, so we're going to have to remember some exponent rules here in order to get this where the bases are the same. So if I have an exponent on the inside of the parentheses and an exponent on the outside of the parentheses, and it's just a single base raised to that power, then what can I do with? Multiply them. Good. So that's going to be e to the 4x power. Okay. Then over here, I have e to the 3x. That's like e to the 3x over 1, right? So if you're multiplying fractions, you'll multiply across the top, e to the 3x, and multiply across the bottom. 1 times e squared is e squared. Okay, then what's the rule? If you divide like bases, what do you do with the exponents? You subtract. Good. So it's e to the 3x minus 2. Okay, and on this side I have e to the 4x. So now the bases are the same, so what can I do to the exponents? Good. 4x is equal to 3x minus 2. Then what kind of equation is that? Linear. So once you know it's linear, you just get all the x's on one side and everything that doesn't have an x on the other side. So 4x minus 3x is x equals -2. Okay? All right, any questions on that one? Okay.